Hi, in this video I'm going to talk about map in C++, unordered map in C++, and at the end of the video I'll do a comparison between them. Let's start with stdmap. stdmap is a dictionary contains key value pairs with unique keys. So it's a collection of pairs, each pair mapped key to a value. Maps are usually implemented as red-black trees. Red-black tree is a type of self-balancing binary search trees, and because the map is implemented using self-balancing binary search tree, it means that search, removal, and insertion operation have logarithmic complexity, log n. Map is sorted associative container, and that means you can print map keys in increasing order. How can you access an element in the map? First, using the keyword @. Access specified element with bounds checking. If no such element exists, an exception of type out of range is thrown. The second way is using operator square brackets. Returns a reference to the value that is mapped to a key equivalent to key, performing an insertion if such key does not already exist. This is an example how to use map. First of all, you have to include the library map, and here I did a declaration for a map. In this declaration, you have to define the type of key and the type of value, which is integer in this case. This is the name of the map, square map, and here I initialized 3 pairs. Each pair has the key as an integer and its square as a value. So the square of 0 is 0, and the square of 4 is 16, and the square of 3 is 9. Because in this line, trying to access the key 2 using square brackets, and because the key 2 does not exist in the map, it will initialize and it will add a new pair to the map with the key equal 2 and value equal 4. In this line, I'm trying to access the key 3 using square brackets, and so square map over 3 is 9. At this line, trying to access the key 2 using the keyword @, and 2 does exist in the map because I added it here. This is why here is printed square of 2 is 4. In this line, I'm trying to access the key 10, which does not exist in the map. In this case, a new pair is inserted to the map with the key equal 10 and a default value, which is 0. This is why square of 10 is 0 is printed. In the last line, I'm trying to access the key 9 with the keyword @, but because there is bound checking and the key 9 does not exist in the map, an exception of type out of range is thrown. There are some methods used to check the capacity of the map. The first one is empty. Used to check whether the map is empty. It returns true if the map is empty, and it returns false if the map has items. The method size returns the number of elements or pairs in the map. Here's an example. We have a map of 3 pairs, and so if square map.empty, this line will return false and the else statement will be executed, and calling size will return 3 because the map has 3 items or 3 pairs. And as you can see in the output, the map is not empty and it has 3 elements. Iterators. There are some iterators used to, it's like pointers to point to some elements in the map. The first one is begin, which returns an iterator to the first element of the map. So it returns an iterator to this element, and returns an iterator to the element following the last element of the map. This is the last element of the map, so end will return an iterator to a point after the last element. Here is an example. How can I use iterators to loop over the map? This is the declaration of the map, and I'm trying to iterate over the map and print its keys and values. So the loop starts with it equal map.begin. This is iterator. This is the iterator. This iterator will point to the first element, and it stop when iterator equal map.end, and this is to increase the value of iterator in each round. The iterator is like pointer to an item or a pair in the map, and in each pair there is key and value. The key I can access it through first, and the value I can access it through second. This is the output of this program. Modifiers. These are functions used to modify the elements in the map. Clear erases all elements from the container. After this call, if you call the size method, it should return 0. Insert element into the container if the container does not already contain an element with an equivalent key. If the map has already that key, it will reject the insertion. In place, it inserts a new element into the container constructed in place with the given args if there is no element with the key in the container. So it's the same as insert, but it creates or construct the pair in a place. So in case you are adding objects into the map, it will avoid any copy or move constructor. So in place is more efficient than insert. Erase removes specified element from the map. Example of modifiers. In this function called print map, I use it to print the map keys and value, and you can iterate over the map item using this method, key and value, but you have to compile your program with std equal C++17. The main function is using this function, the print map. The first line is a declaration of the map, and the key is of type integer. The value is of type character. And this map initially has three pairs. So here, this is our map. This line, it erases the key 3. So after calling this erase 3, it will remove this pair from the map, and so in this line you see 3 pair is removed. In this line I use inplace method to insert a new pair with key equal 1 and value equal p, and in this line you see a new pair is added. One note to mention: even if the map is declared this way, 0, 4, then 3, when you print the value of the maps, it's printed in increasing order. See here, 0, 1, 2, 4, or here 0, 1, 4. In this line I use also the method insert to insert a new pair 2 and C, as you can see here. And in this line I'm trying to insert a pair but with a key which already exists. In that case the insertion is rejected and the old value will remain, which is 2 maps to C. This is another way to change the value of a key. So m of 2 equal r. This will change the value, the key value to r. Here you see 2 and r is, the value of 2 is changed to r. m.clear will clear all the elements in the map, and now the map is empty. Unordered map. Unordered map is a container that contains key value pairs with unique keys. Search, insertion, and removal of elements have average constant time complexity of 1. The elements are not sorted in particular order. So unordered map is similar to the map, but its internal data structure is different. Unordered map is implemented using hash table, but the ordered map is implemented using red-black trees, and so the unordered map is more efficient. It has big O of 1 for operation like search and insertion, but the only thing is that you can't print the unordered map elements in order. Example for unordered map: you have to include this library to use the unordered map, and this is print map, the same function we use for the ordered map. Here is the declaration for the map. Again, you have to define the type of the key and the type of value, and here I initialized with the 3 pairs. So trying to print the value of 2, see a square of 2, it should give 4, and so here it looks like the output is cut, so it should print square of 2 is equal to 4. And in this line I erased the key 3, so it's deleted from the map. After that it will print only 1, 1, 2, 4. And here I emplaced the value the pair 3 and 9, and then insert 4 and 16, and you see these two new pairs are printed here. And it's good to notice that the way the pairs of the map are printed are not in order. So first print 4, then 2, then 1, and then 3. This is different than stdmap, which prints the items in order. This line will clear all the item of the unordered map. This is why you see empty brackets. At the end, let's summarize. So this is comparison between map and unordered map. First of all, regarding ordering, the map is increasing order, but in unordered map there's no ordering, so you can't print the item in order. Implementation: stdmap is implemented using self-balancing binary search tree like red-black tree, while the unordered map implemented using hash table. Performance: search and insertion and deletion time for the map is log of n, while for the unordered map is constant. Thank you for watching.